and read the wonderful message once again. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 2 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. I once got through that whole thing in one breath, but then I darn near passed out. Oh, okay, anyway. So today we're going to go on to section 14.3, and tonight's homework will be 14.3 in the chapter review. Tomorrow during class, we will review for the test, which you will take sometime tomorrow. But before we do any of that, does anybody have any questions from yesterday from section 14.1 or 14.2 that you would like me to look at now? Anybody? All right, then we're going to go on to section 14.3. Now, in 14.2, we looked at arithmetic, which is a fancy way of saying arithmetic, arithmetic sequences. And we dealt with a formula, a sub n equals a sub 1 plus n minus 1 times d, where d was the common difference. Today, we're going to look at, as I mentioned, geometric sequences. So geometric sequences. And the formula is this: a sub n equals a sub 1 times r to the n minus 1 power. And instead of d, which is the common difference, we have r, which is called the common ratio. In arithmetic sequences, we add the common difference to each term to get the next term in the sequence. In geometric sequences, we multiply by the common ratio. So for instance, let's say we had the geometric sequence 1, 2, 4, 8, 16, 32, 64, 128, etc. The common ratio is 2, because 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, etc., etc. How would you find the common ratio? You would take a term divided by the previous term. So for instance, 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 4 is 2. So to find the common ratio, you take a term in the sequence divided by the previous term in the sequence, and that gives you the common ratio. All right, any questions before we go on to some examples? All right, get some examples here. Okay. The directions say, write the first 5 terms of each geometric sequence with the given properties, and then find the specified term. Okay, so it says geometric sequence. So the formula that we're going to use is a sub n equals a sub 1 times r to the n minus 1 power. We are to find the first 5 terms. So we're going to find a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5, and then find the specified term. In this case, they ask us to find a sub 9. All right. Now, what do they tell us? They tell us that the first term is 3, and that the common ratio is 2. Okay, this was all given. They said it was a geometric sequence. Find the first 5 terms, find the 9th term. The first term is 3, the common ratio is 2. Now, just like in arithmetic sequences, where you can take a term plus the common difference and get the next term, plus the common difference and get the next term, etc., you can take the first term of a geometric sequence, multiply it by the common ratio to get the next term. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48, etc., etc. Now, we could just keep going and find a sub 6, a sub 7, a sub 8, and a sub 9 by continuing to multiply each term by 2. But again, this one they asked for a sub 9. What if they asked for a sub 42? You wouldn't want to sit there and keep doubling things, okay? So we're going to look at it a different way. A sub 9, I'm going to use this formula. A sub 9 is a sub 1, which is 3, times the common ratio, which is 2, raised to the power n minus 1, or 9 minus 1. Now, before I go on, does anybody have any questions where I got any of those numbers from? Okay, so then this would be 3 times 2 to the 8th power. Order of operations, we do exponents before regular multiplication. So you would not take 3 times 2 and get 6 and raise that to the 8th power. We would take 3 times, let's see, 2 to the 8th power. 2 to the 8th power is 256. And 3 times that is 768. So we found the first 5 terms, and we found the 9th term. Any questions about this example? Okay, let's take a look at another one. Let's see here. This says, again, they want the first 5 terms of a geometric sequence and then the specified term. So our formula, a sub n equals a sub 1 times r to the n minus 1 power. By the way, note, when you take your test, you can have the following 2 formulas on a card in front of you. The formula that's the arithmetic sequence, that's the a sub n equals a sub 1 plus the quantity n minus 1 times d, and the geometric sequence, which is listed here. So you're allowed to have those 2 formulas on a card. Okay. So we're supposed to find the first 5 terms and the 8th term. They tell us that the first term is -2 and the common ratio is 2. Well, let's see. -2 times 2 is -4. -4 times 2 is -8. -8 times 2 is -16. -16 times 2 is -32. So again, a term times the common ratio gives you the next term in the sequence. To find a sub 8, that would be a sub 1, which is -2, times r, which is 2 to the 8 minus 1 power, which would be -2 times 2 to the 7th power, which would be, let's see here, 2 raised to the 7th power is 128, and -2 times 128 is -256. Any questions about that example? Okay, let's take a look at one that's not quite so nice. Okay. This says, again, the same thing, the first 5 terms of a geometric sequence and the specified term. Okay, so our formula, a sub n equals a sub 1 times r to the n, minus 1 power. Got a little bit too close to the ceiling there. A sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and again they want the 8th term. We're told that the first term is -5 and the common ratio is 1/5. Okay, so now things are going to get a little bit trickier. So I'm going to take a sub 1, which is -5, times the common ratio, which is 1/5. -5 times 1/5 would become -5/5 or -1. Any questions about that? All right. A sub 3 is going to be -1 times 1/5, which is -1/5. A sub 4 is going to be -1/5 times 1/5, which is -1/25. Recall that when you multiply fractions together, you multiply the numerators together over multiplying the denominators together. And then A sub 5 is going to be -1/25 times 1/5, which is going to be -1/125. All right. Again, any questions so far? Okay. A sub 8 is going to be A sub 1 times R to the 8 minus 1 power, -5 times 1/5 to the 7th power. Now, here's where you've got to be really careful. If I put 1/5 in my calculator and raise it to the 7th power, it gives me a decimal answer, 0.0000128. That might be the exact answer. That might be a rounded off answer. I don't know looking at my calculator. Okay. I don't know if you can see that or not, but so what I'm going to do is I'm going to be careful and just stick with fractions. Now, 1/5, that is a quotient raised to a power. We would do this. We would raise the numerator to the power over the denominator to the power. So that would become -5 times 1 over, let's see here, 5 to the 7th power is 78125. Okay. So what have I got now? I've got -5 over 78,125. Can I reduce that? Absolutely. 78,125, 5 goes into it. So I'm going to divide the top by 5 and the bottom by 5. Let's see, 78,125 divided by 5 is 15,625. So I get -1 over 15,625. All right, any question about what I did here or here? Okay. Tell you what, I'll quit asking if there's any questions, but if you have a question, please jump right in and ask me about it, okay? And I appreciate that everybody's got their microphone off while they're not talking. That makes it easier for people listening to understand. Okay. Now, new kind of problem. It says, find the specified term of the geometric sequence with the following properties. All right, so once again, geometric sequence. So A sub n equals A sub 1 times R to the n minus 1 power. It says the first 3 terms are 2, 6, and 18. It says find the 7th term. Okay, so they've given us the first 3 terms. They want us to find the 7th term. The thing they haven't given us is the common ratio. But recall, to find the common ratio, take any term in the sequence divided by the previous term. For instance, let's take A sub 2 divided by A sub 1. 6 divided by 2 is 3. Let's try this a different way. Let's take A sub 3 divided by A sub 2. Oh, that's also 3. So again, the common ratio is 3. Okay? Any questions on how I found that? I promised I wasn't going to keep asking. Sorry. So A sub 7 is going to be A sub 1 times the common ratio to the 7 minus 1 power, which is 2 times 3 to the 6th which is 2 times, let's see here, 3 to the 6th power is 729, and that times 2 is 1458. So a sub 7, 1458. All righty, let's see here. Let's take a look at this one. Find the specified term of the geometric sequence. So again, a sub n equals a sub 1 times r to the n minus 1 power. It says the first 3 terms are 1/2, -5 halves, and 25 halves. And we are to find the 6th term. All righty. So again, I'm missing r. So I can take any term in the sequence divided by the previous term. Let's take, so we'll say r is equal to a sub 2 divided by a sub 1, which is -5 halves divided by 1/2, which is the same thing as -5 halves divided by 1/2, right? Recall that dividing by a fraction is like multiplying by the reciprocal of that fraction. So instead of dividing by 1/2, we're going to multiply by 2, or 2 over 1. Well, now I can reduce this down to just -5. So the common ratio is -5. So that means a sub 6 is a sub 1 times -5 to the 6 minus 1 power, which is 1/2 times -5 to the 5th power, which is 1/2 times. Now, you've got to be careful with your calculator. The base here is -5. So what I'm going to do in my calculator is I'm going to put a left-hand parentheses, then put -5 inside, close it up, the right-hand parentheses, raised to the 5th power. When I do that, I get -3,125. Okay. Now, if I take that times 1/2, I get -1562.5. That is an exact value, so that is okay. I could use that. However, if I want to avoid decimals, then 1/2 times -3125 would just be -3125 over 2. And that does not reduce because 2 does not go into -3,125 evenly. So either of those answers would be correct. But again, I warn you, if you go with a decimal, don't round it off. You've got to leave it as an exact answer unless it specifically says in the directions to round off. Okay. Let's see here. All right. New set of directions. Write the first 5 terms of the geometric sequence with the following properties. So again, we have a geometric sequence. And we're supposed to write the first 5 terms with the following properties. Okay, it says the first term is 2. It says that r is greater than 0. We'll come back to that in a minute. And it says the third term is 18. Okay. Now, r is greater than 0. So that means that R is going to be a positive number. Okay, it doesn't tell us what that positive number is yet, but we do know that it's positive. If we look back here, let's see, this one, R was, oh, R was what? It was a negative number, wasn't it? -5. Back here, R was 3. So R can be positive or negative, but in this case, it's going to be positive, and let's see what happens. Okay. So we can't really find the common ratio easily because we don't have two consecutive terms in the sequence. But think back to what we did yesterday. Let's take the fact that a sub 3 equals 18, along with plugging that into our formula. So in other words, we can do this. We can say a sub 3 equals a sub 1, which is 2, times r, we don't know what r is yet, to the 3 minus 1 power. Or we could say a sub 3 equals 2r squared. All right? But we also know that a sub 3 equals 18. That's given. So what we've got is a sub 3 equals that, and a sub 3 equals that. Think about what we did yesterday. We had two different ways of describing the same thing. You know, for instance, we could say, today is Wednesday, today is hot, therefore Wednesday is hot. A sub 3 equals 2r squared, a sub 3 equals 18, therefore 2r squared equals 18. I just love it when my voice cracks. Alrighty. Now, yesterday at this point, we'd be solving for D. Here we're solving for R. So the next step is to divide both sides by 2. So we get r squared equals 9. Now, eventually, we're going to get to chapter, oh, I can't remember, I think it's chapter 9, and we will deal with roots and square roots and cube roots and all of that extensively. But right now, we're going to talk just a little bit about it, just enough to be able to do these kinds of problems. Think about this. What squared equals 9? Well, 3 squared equals 9, doesn't it? What about -3? Does -3 squared equal 9? Yes, it does. And the way we can get that is to do this. And this is getting formal with it. If we take the square root of both sides, we're going to put a plus or minus outside here, and we get r equals plus or minus 3. That's acknowledging the 3 and the -3, okay? So we've got r equals -3 or r equals 3. But wait a minute. We had this restriction applied at the beginning of the problem. So we're going to disregard the -3 and just go with r equals 3. Okay? Because both 3 and -3, the quantity squared, give you 9, but we were told up front that r had to be greater than 0 or positive. All right. So now I know that r is 3. Okay? So now let's go back and fill in the missing terms. Well, if r is 3, a sub 1, 2 times 3 would be a sub 2, which is 6. A sub 2 is 6. 6 times 3 would be 18. 18 times 3 is 54. And 54 times 3 is what? 162, I believe. And there we have the first 5 terms of the geometric sequence. We good to go on? I think so. All right. New example. Again, find the first 5 terms of a geometric sequence. So here we've got a sub n equals a sub 1 times r to the n minus 1 power. We need to find a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. The first term is 2. The third term is 50. But now we're told that r is less than 0. So for this example, the common ratio r is going to be a negative number. All right. We're going to do the same process we did on the previous problem. We're going to take the fact that a sub 3 equals 50, and we're going to say a sub 3 equals a sub 1 times r to the 3 minus 1 power. A sub 3 equals 2r squared. Oops, I didn't write that correctly. Come on, eraser. 2r squared. But a sub 3 also equals 50. We were given that information. So a sub 3 equals this, a sub 3 equals that. So this equals that. Okay. So now we're going to solve this equation for r. The first thing we'll do is divide both sides by 2 to isolate the variable. So now we have r squared equals 25. We'll take the square root, so we get plus or minus 5, because 5 squared is 25, and the quantity negative 5 squared is 25. But wait a minute. We were told this time that r was negative. So we're only going to consider the negative 5, not the positive 5. Okay. So a sub 1, which is 2, times negative 5 would be a sub 2, which is negative 10. Negative 10 times negative 5 would be 50. 50 times negative 5 would be negative 250. And negative 250 times negative 5, let's see, what is that? So 250 times 5 is going to be positive 1250. Notice when r is negative that the terms alternate in sign. Because when you take a number times a negative number, the answer is going to have the opposite sign of the original number. All righty. Okay. Everybody doing okay? All right, let's go on. Let's see here. It says, find the geometric means to be installed or inserted in each geometric sequence. Remember yesterday we put some arithmetic means in the middle of a sequence. Now we're going to put some geometric means in a sequence. It says, let's see, find the geometric means to be inserted in each geometric sequence. So I'm using, again, a sub n equals a sub 1 times r to the n minus 1 power. It says insert 3 positive geometric means between 2 and 162. So I know that the first term is 2. I know that I'm supposed to put 3 positive geometric means in the middle. So that means that the 162 is the 5th term. I've got the first term and the last term and 3 in the middle. So the first, the last, and 3 in the middle. Okay. And it also says positive. Let's see what that's going to, where that's going to come into play. Well, I don't have r, and I'm not given 2 consecutive terms to find r. However, I do know that a sub 5 equals a sub 1 times r to the n minus 1 power. So a sub 5 equals 2r to the 4th, and a sub 5 also equals 162. which means this equals that. So my equation becomes 2r to the fourth equals 162. Pause briefly for you to get caught up. This is what I call ketchup with mayo. That's my first bad joke of the day. Some of you relish the thought, I'm sure, and are thinking, just let us alone. Okay, sorry about that. All right, now we're going to divide both sides by 2 to isolate the variable. But now I'm going to take the fourth root. So r is going to be plus or minus the fourth root of 81. Wow. What are we going to do with that? Well, think about this. What number raised to the fourth power is 81? Let's see. 1 to the fourth power is 1 times 1 times 1 times 1, whoops, times 1, which is 1. So that's not right. 2 to the fourth power is 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. That's not right. How about 3 to the fourth? 3 times 3 times 3 times 3, 9, 27, 81. Oh, so r equals 3, but it could also equal -3, couldn't it? Because -3 to the fourth power would be +9, -27, +81. Okay. So what I'm coming up with is that r could be +3 or -3. However, if we go back to the instructions, it said insert 3 positive geometric means. If I use r equals -3, 2 times -3 is going to be -6, times -3 is going to be +18, times -3 is going to be -54, and that's not correct. So what I'm going to have to do is use just the positive common ratio, okay? So if I use +3, 2 times 3 is 6, times 3 is 18, times 3 is 54, times 3 is 162, and there are my 3 positive geometric means. So don't ignore those little things like the common ratio is positive or the common ratio is negative, okay? Okay, let's see here. How are we doing? We got lots of time. I'm trying to look at one that's good. Ah, here we go. All right. This says, find the geometric means to be inserted in each geometric sequence. Same instructions as before. It says insert 3 geometric means, and then it says 2 positive and 1 negative between -64 and 1024. All right. So the first term is -64. We are to insert 3 geometric means. The last term is -1024. Okay, so I know the last term is the fifth term because I've got the first term, 3 geometric means, and then the last term. All right. Now, instead of saying that the common ratio is positive or the common ratio is negative or the means are positive or the means are negative, it says we've got, what did it say? 2 positive and 1 negative. Well, let's proceed and see if we can find out what r is, and then we'll talk about that again. All right, so we're going to use the fact that a sub 5 is a sub 1 times r to the 5 minus 1 power. A sub 5 is -64 times r to the 4th power. But we also know that a sub 5 is -1024. 24. So that means that this equals that. So this equals that. We're trying to solve for r. So first of all, let's get r to the fourth power by itself. So we'll divide both sides by -64. So r to the fourth power equals, let's see here. Okay. Negative divided by negative is positive, and 1024 divided by 64 is 16. Okay. So r to the fourth equals 16. So once again, we're going to take the fourth root. Whenever we take a root that's even, like square root or fourth root, we get a plus or minus. So r is going to be plus or minus. Let's see, the fourth root of 16. What to the fourth power is 16? Well, 1 times 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the fourth power equals 16, and -2 to the fourth power would also equal positive 16, because negative times negative is positive, times negative is negative, times negative is positive. Remember, if you're multiplying together an even number of negative factors, the answer is positive. An odd number of negative factors, the answer is negative. So r could either be -2 or r could be +2. But now let's go back to the directions again. It said, let me find it here. We want 2 positive and 1 negative geometric mean. Let's take the -2 and see what happens if I use that. If r is -2, -64 times -2 would be positive 128. 128 times -2 would be -256. -256 times -2 would be positive 512. Does that give me 2 positive and 1 negative? It does. So this works. Well, let's see what happens if we try that. Okay, let's try that one in red. So if a sub 1 is -64, -64 times 2 would be -128. -128 times 2 would be -256. -256 times -2 would be -512. And that would then be or let's see, that would be -1024. That doesn't give me 2 positive and 1 negative. It only gives me 3 negative geometric means, right? So that's how we can determine that r has to be positive in this scenario. All right. Okay. I'm looking here to see if by some chance. All right. Just wanted to make sure it wasn't one of you sending me a message to deal with right now, and it wasn't, so that's good. We'll go on. Okay. Find a geometric mean to be inserted in each geometric sequence. So it said a geometric mean. That means we're going to insert one geometric mean. Okay. So since it's a geometric mean, we're dealing with a geometric sequence. And we're given 2 numbers and asked to put one geometric mean in the middle. It says to put them in between 2 and 128. So I know the first and the last term, or the first and the third term. All right. Well, let's see here. I know that a sub 3 equals a sub 1 times r to the 3 minus 1 power. So a sub 3 equals 2r squared. But I also know that a sub 3 equals 128. Therefore, 2r squared equals 128. If this looks a lot like the last problems, it is a lot like the last problems. We've got that concept of, today is Wednesday, today is hot, therefore Wednesday is hot. Two different ways of describing a sub 3 gives us the following equation. Divide both sides by 2, r squared is 64. Take the square root of both sides. R equals, what times what is 64? 8 and negative 8. So R could be 8 or negative 8. That's all they tell us. There's nothing in the instructions that says the geometric mean is positive or it's negative or R is greater than 0 or R is less than 0. So basically we've got two possible answers. If R is negative 8, this would be, let's see, negative 16, and then negative 16 times negative 8 would be negative 128. Or if R is 8, this would be 16, and 16 times 8 is 128. So we actually have two different possible values for our geometric mean. Okay. Any questions about that?
Yeah, on that question, do we list both those possible answers, or can you just pick one? They are going to ask for both of those.
Yep. In fact, I'll put the word or in there.
Okay.
Yeah, because it doesn't give you any reason to eliminate one of them, so you would list both of them. Yes. All right. Let's look at another example. Are we good to go on or need a little more time? I can wait, not a problem. I discovered long ago that I get paid the same whether I rattle on really fast or I just sit here and do nothing. I get 2 cookies and a glass of milk. So there we go. All right, are we good? I'll assume the tip of the hat means yes. Okay. Here's another scenario where it says, find the geometric mean between 3 and 243. So a sub 1 is 3. We're going to find a sub 2, and a sub 3 is 243. We're going to use a sub n equals a sub 1 times r to the n minus 1 power. Pretty much like the previous problem. So a sub 3 is 3 times r to the 3 minus 1 power. A sub 3 is 3r squared, but a sub 3 is 243. So 3r squared equals 243. Divide both sides by 3, r squared equals 81. Take the square root of both sides. R equals plus or minus 9, right? 9 squared is 81, negative 9 squared is positive 81. Again, we're going to have two answers because there's nothing that says it's got to be positive or negative. So if R is negative 9, we'd have negative 27. If R is positive 9, we'd have positive 27. So we've got two possible geometric means, and you would list both of them because there was nothing to say get rid of any of them. Okay, so this is the last section of material that's going to be on your test tomorrow. Your homework tonight is to finish up to do 14.3. Also finish up anything from last night if you haven't gotten it done, and to do the review problems that are getting ready for the test tomorrow. Okay, during class tomorrow, basically what I'm going to do is answer questions. If you have any questions, we'll deal with them. If you don't have any questions, I'll probably do a somewhat of a review, kind of go back and look at some examples of each section. Okay. Also, I will be here tomorrow for an office hour at 10 a.m. So far, I've only had one student show up for an office hour, and they had questions to do with WebAssign, just how it worked and things. But I'm here whether you come or not. Okay. So do you have any questions right now? Now is the time to ask. Otherwise, we're going to say goodbye, and I'll be back tomorrow. So anybody, any questions about anything to do with the assignment or tomorrow's test or anything? Okay. Then I will stop the recording.